for any two non-empty sets A and B, if A is a subset of B, then we need to prove the following. Okay, let us begin. Now, what we'll do, we will first consider an arbitrary element which is represented by the ordered pair A comma B. So let A comma B an ordered pair such that let A comma B be an arbitrary element. It's going to be an arbitrary element such that we consider the ordered pair A comma B to be a member of the Cartesian product of A with itself. Now, what does it mean when we say that the ordered pair A comma B is a member of the set which is the Cartesian product of A with itself? The first element of the ordered pair, which is A, it's going to belong to the first set A. And we have the second element, which is B, that is going to belong to the second set, which is A. Fine. That this means that A is a member of the set A and B is a member of the set A. However, since it is already given in the problem that A is a subset of the set B, what does it mean? It means that if we consider an element A to be a member of the set A, then that same element A is also going to be a member of the set B. That's the definition of a subset. And we can also say if we consider another element B to be a member of the set A, then this element B is also going to be a member of the set B. We're going to employ this. So first we have A belonging to the set A. So if A is an element of the set A, it immediately tells us that that same element A is also going to be a member of the set B. Fine, since A is a subset of B. And for the second part of the statement where B belongs to A, and we have B belonging to the set A, so we're considering this element that immediately tells us that same element B is also going to be a member of the set B. Now we're going to rewrite this statement. We're going to consider this and this. So we have A belonging to the set A followed by B belonging to the set B. And we're going to consider B belonging to the set A, that is statement, and then we have A belonging to the set B. So what does it mean when we say that A belongs to A, comma B belongs to B? This means that if we consider the ordered pair A, comma B, that is going to be a member of the Cartesian product of A and B. Fine. And we're saying here that B belongs to the set A and A belongs to the B, or in other words, we can say A belongs to the set B, B belongs to the set A. We can say that the ordered pair A comma B, the order is very important since we're considering this to be first in the ordered pair. So we have this belonging to the Cartesian product of B and A. Now when we combine the two statements, so this tells us that the ordered pair A comma B, this is going to be a member of the Cartesian product of A and B, and the N is going to correspond to intersection. We have the Cartesian product of B and A. So we started out by considering an ordered pair A comma B, which is a member of the Cartesian product of A and A, and we were able to show that the same ordered pair A comma B is also a member of the set, the Cartesian product of A and B intersection with the Cartesian product of B and A. So this simply tells us that the Cartesian product of A with itself, this is going to be a subset of the set, the Cartesian product of A and B intersection with the Cartesian product of B and A. Hence proved.